Thank you, Phil. Thank you all for coming. I appreciate it. So as Phil mentioned, we're here to talk about specifically talk about baselining, and really we're gonna take an endpoint-centric approach to that, using endpoint telemetry to do baselining at scale. Baselining is a concept I think that everyone in this room is familiar with, right? So it's pretty straightforward. You take a system in a controlled environment, you understand what it should look like in a known good state, and then that's a jumping off point for comparative analysis that allows you to, moving forward, separate what's good from what's bad, right? That's the ultimate objective of baselining. It's a positive security approach, right? So this is not the case where you make a list of things that are bad, and then you ask systems to tell you when those types of things happened, or you try to identify them in data, and then you investigate them. Baselining's the opposite, right? So you want to take what you know to be good, and you want to set that aside, and then you want to be able to look pretty effectively and efficiently at what's left. So this is not a new discipline, right? There's a ton of tools available to do this. You've got on the memory side, right? So if you just look at the SANS reading room, like let me Google that for you. There's a million of them out there. Some really good talks, some really good papers, taking a bunch of different approaches, using a bunch of different tools, right? So really common one, just to take memory, use something like volatility. Again, a lot of good papers and some many past SANS talks that touch on this. Take the platform of interest, identify what it looks like, what processes are running when it's a known good state, and then you just run a straight diff, right? This came up in Troy's keynote yesterday, right? Doing the same thing, taking that and applying it to guests in an Azure environment or any other virtualization environment, right? Just snapping those things, taking them, throwing an entire virtual disk into X-ways and just figuring out what differs. Using things like survey tools, so obviously OS Query, a bunch of mention here. We'll hear more about that this afternoon. Using a lot of the sysinternals tools, right, for Microsoft, so just recording on an ongoing basis things that are happening on a system in a controlled environment, and then comparing that to what happens when you introduce something new or put that system into the wild, right? And then logs, right? So it's we have access to a lot more information. It's becoming much easier to gather and to gather at scale. Logs are still a super valuable source of baselining data. So the upside is that there's a ton of precedent, a ton of tools, a ton of methodology, and a ton of automation available if you want to baseline a system. The only downside, if there's a downside, is that what we really need to do is baseline hundreds, thousands, hundreds of thousands of systems at a time, right? So particularly as folks, doing incident response or detection at scale, you need to come into an environment and you need to really, really quickly wrap your head around everything that's happening, and you don't always have the luxury, or you very rarely have the luxury of knowing what those systems look like when they were put in service, right? You may never be able to get back to that state again. If you're lucky, the company knows, the target environment, someone there has access to that, but it's very, very rare that you're ever going to see it, right? And the reality is that when you put a system in service, like that system's going to change. Software gets updated, usage patterns get updated, software gets changed, users' requirements and behaviors change. So what we're going to talk about at a pretty high level, right, and just to understand the methodology that we use, and we'll dive into some specific numbers that we see when we apply different approaches to baselining. But using endpoint telemetry to accelerate baselining of like significant numbers of systems at scale, right? Same approach that we take when we're baselining a single system, but applying that in a way that we can baseline tens of thousands of systems, 100,000 systems in hours, days, or days at most, ideally. So the real difference in approach, and what this reflects what the market's doing, right? There's tons of tools. EDR as a discipline is obviously exploding, right? And this is like there's a recognized need to go from doing things point in time to doing things on an ongoing basis. And you can liken this to just taking a picture of something with a camera to recording full HD video, right? Same thing applies. So that point in time approach works, but the point in time approach is not necessarily reflective of reality, right? So you can take a look at a thing on day 0, that's great. You can introduce something else in that system. You can put that system in service. You can compare them. But it's only as effective as your sample size, right? Or your ability to continually pull data. There are obviously some tools out there that can do that even in an ask and get response method really quickly. What we want to do is take that, we want to operationalize whatever the tool may be, and there's a number of them. We want to operationalize that, and we want to stop baselining endpoint at a time, and we want to start baselining systems like enterprise at a time, right? Look at everything all at once in an operational environment reflective of the reality of that computing environment. And then we want to start finding things that are good. We want to set those aside. And then we want to start letting everything else rise to the surface. So this all starts with collection, right? So you can't analyze what you can't see. You've got to have a means to get this data in. Again, tons of tools available to do this, right? There's many, many more that aren't on this slide. So we happen to be a CB Enterprise response shop. Again, tons of OS query users here. We're OS query users as well. You've got commercial tools, you've got open source tools, you've got a lot of platform native stuff, so Microsoft's doing a really good job. Sysmon is a fantastic tool for getting an almost identical data set to the one that we and many of you use for free, right? All you've got to do is figure out how to collect that data and then analyze it. And the tools to do that are getting better every day, right? So what does that collection look like? On average, we see around 4,300 processes on one endpoint in a day, right? And that converts into about 86,000 events. 86,000 is probably a conservative number. So we'll stop here for a second and explain exactly what I mean when I say telemetry, like endpoint telemetry, and what exactly an event constitutes. So processes are straightforward, right? Binary on disk, gets executed. Events are all of the things that process does, right? And you can turn the dial on that up or down, depending on your needs and your ability to ingest and analyze that data. So that 86,000 is file modifications, registry changes, network connections, module loads, cross-process events. That dial again can get turned way up. So if you're using a DLP solution, you're using another type of system that's capturing read information, handle information, mutex, things like that. That number can go. You can hit close to 1 million on a single system, right? We've seen systems that capture UI information and things like that for context. Those things are capturing a tremendous number of signals, right? So it's a really conservative number. End user systems tend to be noisier than servers, right? So you're going to have a smaller number of things executing on a server typically, but longer running processes, and sometimes you have varying degrees of change. So if you just take like a really moderately sized enterprise, right, 1,000, you start, I didn't really need to do the math for you, but you start to get into some meaningful numbers, and if you explode this to what we all think of as an enterprise, right, so probably around 70, 80, 100,000 systems, you're dealing with some pretty meaningful amounts of data at that point. The good news is, and again, this was mentioned in the keynote yesterday, once you figure out how to take in that data, right, and you get through the mechanics, which are becoming easier every day, of ingest, storage, and being able to ask questions of that data, it works to tremendous advantage, right? We're going to kind of see some of that now. So you get your data coming in, we've solved collection, and now we need to deal with filtering and analysis. So analysis, obviously, at the end of the day, you've got to have humans looking at some resultant set of events to do this really, really well, right? The key is to not have your humans looking at the same things over and over again. So whatever platform or system you choose for collection and however you choose to store that, the single most important thing is that feedback loop between your analysts and your filtering mechanism. When a human in particular makes a decision, that's a really expensive operation. You want to codify that using all available criteria, and you got to plug that back into your filtering system so that your humans aren't looking at that same type of thing again, right? And so this kind of comes down to the concept of aperture. Collect it all, right? You can store it all, and we talked yesterday, kind of brought up the concept of retrospective analysis, right? So the most important thing to figure out, given that you can collect it and store it, is what you can afford to evaluate right now, right? And this is heavily dependent on the size of your team, the types of things you're looking for in the environment. Are you in a short-term IR situation where you already have a number of indicators, you've already got a place to start? Are you more of a service provider? Are you in a long-term engagement there? Is it your own enterprise where you're going to be watching for a really long period of time and have the luxury of kind of opening up that funnel and controlling what comes in and like slowly expanding that over time. What can you afford to evaluate, and how are you going to measure it? Again, every time a human makes a decision, based on these criteria that you set, you need to capture that. So criteria, for our purposes, are attributes or combinations of things that we see flowing in from endpoints that we care about for one reason or another, right? And they can be super broad. So like the very simplest one, which is extremely broad but really effective, is just to say a process starts, right? We take a hash of the binary image from which that process came, and then we check that and see if we have it. Have we adjudicated this binary before, period? Like really, really simple. If we haven't, it gets subject to binary analysis, so dynamic, static, and it gets put in front of a human, right? It seems like an expensive operation, but when you start to scale it, you actually get some pretty significant economies, right? And that's a very effective backstop against things that you can't predict, right, or that you didn't see coming. You can also take the approach of saying, all right, well, small team, tremendous amount of data. Let's set system services aside for a second, maybe even set signed software aside, and now let's just look at stuff that's not signed, right? Like really, really simple approach. It's a good first cut. Let's understand that. Let's get our feet wet. Like start to let filtering take hold. Let some of our analyst decision take hold. See what we have left, and then we'll take another cut. Those criteria can obviously get as specific as you want, right? And we'll see some of the attributes that we use to define those. So this is like simple event rate, right? So this is the event rate into analysts from an organization we baseline. I think it's around 65,000 endpoints, right? So plug it in, start getting data, got our filtering criteria set. In this case, I want to say our aperture is probably around 75%, right? We're not looking for 100% of things on day one. We're trying to get a really good understanding of the things that we suspect based on past measurement, right? So you take those criteria, and every time analysts make decisions, you learn whether those things are likely or unlikely to be good or bad, right? And you can measure that over time and use to prioritize. So around 60,000 endpoints end up with around 70,000 events, right? So that's too much. I don't know how many analysts you have. I would love to have more, but I don't have that many. There are patterns in there, right? So there are definitely efficiencies that you can glean. If you control your platform, varying degrees, the analysis tools that you use and the feedback mechanisms that you build can be used to get through this. But 70,000 is a pretty unrealistic number for humans to look at and make good decisions, right? So we take a first pass at that, and we just say, for everything that comes in, it matches one or more sets of criteria, right? So a process comes in, it's unsigned. That's one set of criteria, right? It's really, really broad. So we've now kicked that thing out. Maybe it also got flagged because it wrote an auto-runs key. It also got flagged because it was an unsigned binary making a network connection, right? Like really, really straightforward. It's simple. But that's the first pass that you take is your criteria. You match that up with a hash. So this works well for a lot of the low-hanging fruit, right? You get into an environment, they've got line of business applications, right? They've got things you necessarily would never have seen before. They're specific to an organization, or maybe not specific to an organization, but they're not things that you're going to see commonly on the platform, but they're easily explained, right? And their behaviors are pretty well known or inferred based on prevalence and things like that. So you can take this approach. It's really good for getting rid of those things. The important thing to keep in mind as we go through and talk about all this is that at every stage, it's all like every one of these decisions that you make and everything that you suppress or start to filter out moving forward has to be tied back to those criteria. And the reason for that is really straightforward in that you're going to learn how to look for things in new ways, right? And you're always going to be coming up with new filtering criteria. You're even going to be putting things in there directly, once you get out of this baselining process. This converts directly into finding things that are bad, right? So you are going to be looking explicitly for things that are bad using similar criteria. And you don't want to blind yourself, right? So there is never any concept of this binary is good, right? That's just not a thing. Good things go bad all the time. So when we do that, right, that takes us just using those that set of criteria. That's half, right? 35,000 is still too many good decisions for people to make in a reasonable amount of time. So we're not there yet, but that's half, right? It's a good enough first cut. The obvious problems we have there are with things like dual-use tools, system services, right? So dual-use tools being pretty much all the shell utilities, right? remote access tools, all the things that you find in a system, administrative utilities, they're there for good reason. They should be used by some people. They can absolutely be misused by other people. And it's not always easy to tell or codify what those conditions are. And then system services, right? So we obviously know from lots of experience that the very first thing you do when you get on a box is like, get the heck out of your own payload, right? So you migrate into a system service, and then you've definitely, like, you've made it significantly more difficult for someone to separate wheat from chaff and identify the things that you're doing versus the thing that the system's doing, right? So we add some more criteria to this now, right? So we take criteria plus hash, and then we add some relationship data. We add the writer, right? So you can take that as a piece of criteria. So this is huge, right? So pedigree matters a lot, like matters tremendously. So you've got a binary on disk, right? So say you've got an SSH client that shows up on a Windows box, right? It's definitely not a thing that's there by default, but it's a thing that you can expect to find in pockets of most organizations. It's not surprising. Where it came from matters, right? If that thing ended up getting written by a Word document, which is not likely to happen, possible, so that's like pedigree matters, right? That's a case where that thing definitely stands out. If it was written by a software provisioning system, right? So if it was written by SCCM or it's written by Altiris, if that thing was pushed out by the IT organization, that's a totally different conversation at that point. It may or may not be good, but it's still a conversation. You know where to go to get an answer to your question, and you've got some insight into pedigree. Parents, so parents matter. Real simple example here in terms of parent and child, right? So look at all usage of really common information gathering utilities. So look at Who Am I, look at net.exe, things like that on Windows and on other platforms as well. But legitimate information gathering utilities, legitimate administrative utilities, also really frequently used when you get on a box to figure out where am I, what can I see, what privileges do I have, right? So those are things that we care a lot about looking for. And in some environments, you will never ever see them unless it's something bad. In other environments, you'll see that all the time. So a really good example here is that we'll very often get into organizations where they've got some type of tool or some type of administrative system in place every time somebody logs in, right? gpscript.exe now is running command.exe, which is running all these things. So again, pedigree matters, right? If someone terminals into a box, gets into command.exe, and then starts doing these things, that you can bucket up and you can look at that in a certain way. If gpscript all of a sudden does that, and now you can look at prevalence and frequency and see that, well, this happens every time anybody logs in this organization with 50 or 60,000 endpoints, right? Now you can approach that in a different way. So you can use those things to your advantage, and again, you kind of chain them all together to describe in a very concrete way what's good, right? If this, and that, and this, then we say it's okay, we set that aside. And then you can start to layer on top of that some process metadata, so taking user ID and command line, right? And the command line, so another simple example, right? So take IS worker process, right? So if that thing spawns a shell, so you maintain a big array of all your shell utilities on your platform. If your web service, so say it's Windows, you got IS worker process, spawns PowerShell, right? That's something you probably want to look at. Once you start to dig into it further, you start to look at the command line, you start to look at the user context, and you say, all right, well, like every single time it does it, it runs this one script, right? And maybe it passes it one piece of information, maybe not. Now you've got some context there, you've got some repeatability, and you can start to figure out, all right, well, this is, you know where to go to ask the question, right? You've got a system that's doing a repeatable thing. You can chain that sequence of events together, so you're still always going to look for web servers that are spawning shells, right? That's, again, it's abnormal. But in this one case, you can say that's okay, and you can set that aside. Again, chaining all these criteria together. So where does that get us? Now we're down to like 10,000, right, in this case. So we've gone from 70,000. We took our first pass, criteria and hash. That got us about halfway. It's a pretty good cut. Now we're at 10,000. We're not at the promised land yet, but we're getting there. And so the last two dials that we have to turn there are scope and permanence, right? Where scope is, for every decision that I make, how do I want to apply this moving forward, right? And so this is where you really start to see yourself like taking some pretty great advantage of filtering. So when your human makes that decision, which again is the most expensive part of this whole process, if it's, take your PowerShell example, right? So your web server. That's not a thing that we expect to see all over the enterprise. And if you've got 100 web servers or even 1,000, that's probably not a thing we expect to see on most of them. So we're going to apply that to one of those systems, or we might apply it to several, but we're not going to apply that to all. In the group policy example, right, where we've got a group policy, GP script is running a command prompt, which goes and gathers a bunch of system information, sends it somewhere internal, it's fine. That's the thing that we want to scope to everyone. And then similarly, we want a concept of permanence, where we say, all right, well, like just this once, this thing's okay, right? We have information about pedigree, we can see where a thing came from. It's not a thing we expect to see a lot, and we're still, we're not really comfortable making a suppression decision about this long term, so we're going to hide it once. You can hide it forever, and I put up my quotes of forever to us, for instance, is 90 to 120 days, right? So if we say, apply this to everybody in the organization, take even the GP script example, right? Apply this to everybody in the organization. By default, we apply that, and we age it out after like 90 to 120 days, right? That gives us some scale. It gets us over that hump. It helps us get that initial set of events that our analysts have to look at down. But also gives us a mechanism that will save us from bad decisions, in a semi-automated way, right? And that's not perfect, but undoing a bad thing automatically after 90 days is better than not at all. And then you've got some things that are really forever, right? So you might say, okay, like this group policy thing, never going to go away. Every 90 days, now we're getting like 1 million events coming in. We don't ever want to see this again. And you can have the very special button that the person can push that makes that thing permanent, right? And that's it, right? That gets us down to that promised land, which is never zero, right? So we're baselining, and that baseline is alive. What we want to do is we need to get to a manageable enough number for given our endpoint count. And the idea is that we never stop, right? This is not a point-in-time baseline anymore. This is intended to be very much a living thing. So at any point in time, you can take this set of filtering criteria you've developed, these decisions that you've made, and you can look at that. You can even diff that, right? So if you just imagine making a list of all these filtering criteria, so all of these different attributes that you've chained together and say these things are okay when they apply to this set of systems, you could store those point in time, and you can see how those trend. And those things can be used as, for QA, QC. They can be used to help you understand the concept of drift in an environment, like how often on average are the environments that I'm looking at changing over time, and what might I need to build in or do to account for that. And again, the goal here is always to find things that are bad, right? So you're taking a positive approach here to suppressing what's good. The overarching goal, or the only goal, right, is to help you bubble up the things that are bad faster. And so by applying this over time, we've been able to scale this pretty tremendously, right? I mean, looking at things, as a rule, having humans look at everything is a really expensive operation. But you can see just by layering together some really, really simple attributes, putting them together in a simple way, and then just architecting a system that has the proper feedback loops, you can do some really, really effective baselining. And then on the tail end of that, you can do some extraordinarily effective detection, right? The goal is to cast a net here that's wide enough and manageable enough that it gets to be increasingly difficult to slip through. Right? That's all. So.